Hello everyone, I would like first of all today thank organizer for inviting me today. Let me introduce myself. My name is Rashid Akbar. I am doctoral student of Samarkand State University in Uzbekistan. My co-authors are Akhatf Akmal and Nazar Faizullah. They are my supervisor and both of them work Samarkand State University. Today I present our research, which is the same size distribution of data based on supervised clustering algorithms. Nowadays, data analysis, which is identifying hidden contents from a dataset and separating them into useful, reliable, and interrelated data groups, is one of the modern research topics. In the modern digital age, the increase in the volume of data flow increases the relevance of this research topic. Because of the increasing of data flow, people's natural data analysis capabilities are limited, and the process of extracting meaningful information from big data becomes more complicated. In such a situation, the most effective solution for finding hidden patterns in data is unsupervised learning based on data clustering approaches according to certain criteria. Unsupervised clustering is an approach to group data by grouping or separating those with similar patterns and those with different patterns from the data without human intervention. In these clustering approaches, the group of data mainly focuses on characteristics such as similarity and uniqueness of the data, and usually ignores or does not consider the number of elements in the groups to be very important. But in real life, there are such problems that not only the similarity and differences of data are important in solving these problems, but also the equality of the number of elements in clusters is an important factor. Therefore, achieving equal size distribution based on unsupervised clustering algorithms was taken as a major research objective. Our methodology. In this research work, first of all, literatures related to the solution of the problems was analyzed. It was found that most of the literature covered only the content of unsupervised clustering algorithms. Only in some literatures, studies related to the size of clusters have been conducted. However, in these literatures, the problem of clustering of the same size has not been considered. During the research, the selection of the characteristics of the data was also considered in order to divide the data into clusters. In this process, the ASCII codes of the characteristics in the data were used and the following features were extracted. At the next stage of the research, the data were distributed using existing unsupervised clustering algorithms based on the features extracted above, and the size of the clusters were determined. The research process showed that existing unsupervised clustering algorithms are not always effective in solving the given problem. Therefore, a new vector model scored-based clustering algorithms was proposed during the research. These steps are described in the following sections of this article. Opportunities of existing unsupervised clustering algorithms to distribute data into clusters of equal size. Hierarchical clustering. This clustering is one of the widely used unsupervised algorithms for clustering data into groups. Hierarchical clustering mainly used two approaches. These are agglomerative hierarchical clustering and divisive hierarchical clustering. In both approaches, the clustering results can be illustrated using a dendrogram. We can see it figure 1. In hierarchical clustering algorithms, grouping is done after the complete cluster hierarchical is built. That is, after all the elements in the collections are formed as branches of the single tree. The branches of the tree corresponding to the required number of clusters are separated. This process can be visualized using the diagram shown in Figure 2. In Figure 2, line M in the first diagram divides objects into two clusters. Line N in the second diagram divides objects into three clusters, and line L in the third diagram divides objects into four clusters. As can be seen, only for the objects in the third diagram the size of clusters is almost equal. It can be concluded that it is not always possible to divide the data into groups of the same size by means of hierarchical clustering, which is usually depends on the state of the objects to be clustered. K-means clustering. The K-means clustering algorithm is a center-based grouping method, and the objects in the set are clustered according to which of the central points known as centroids are close. The number of centroids is the same as the number of the clusters requested. In Figure 3a, the objects are divided into three clusters, and the size of each cluster is almost the same. But if the objects are divided into two or four clusters, the size of the clusters will be very different from each other. In Figure 3b, it can be seen that two clusters are large in the size, and the others two are small in the size. Figure 3c shows a perfect set of objects that are relatively evenly distributed over space. When this set is divided into an arbitrary number of clusters, clusters of almost the same size are formed. Bisecting K-means clustering. The Bisecting K-means algorithm is an improved interpretation of the K-means algorithms, which is more efficient than K-means in splitting into clusters of equal size. Because the main idea in Bisecting K-means is to create a new clusters by dividing a cluster with a large size, a large sum of squared errors. This process is shown in Figure 4 can be seen. In Figure 4, the first set A is given. Collection A is divided into clusters B and C based on the Bisecting K-means algorithms. When the number of clusters is equal to 3, cluster B is divided into 2 since there are more objects in the cluster B than in cluster C. Then 3 clusters C, D, and E are formed. When the number of clusters is equal to 4, cluster C is divided into 2 since clusters C has more objects than clusters D and E. After that, and 4 clusters named D, E, F, G are formed. As the number of clusters increases, the same process are continued. DBSCAN is a density-based clustering algorithm. This clustering method is more powerful than other clustering methods. In other words, this algorithm is the most effective approach to identifying hidden meanings. But this algorithm is ineffective in solving the problem of equal clustering, because in the DBSCAN clustering method it is impossible to specify the number of clustering in advance by the user. When the number of clusters changes depending on max, dist, and mean points, it is impossible to say exactly how many clusters will be formed in advance. In addition, some information contained in the data to be clustered may not belong to any clusters, that is, they may be considered as noise. Taking into account these shortcomings, it can be said that it is impossible to use the DBSCAN algorithms in solving the problem of equal-sized clustering of data streams. Clustering algorithms based on square root of vector models. In this research, a new clustering algorithm is proposed in order to solve the problem of distributing the data flow into clusters of equal size. This clustering algorithm is based on the construction of vectors directed from the coordinate or origin to the future coordinates of objects. It is known that any n-dimensional vector A with coordinates has a length of a certain positive number, and it is founded by Formula 5. This proposed algorithm is based on dividing the squares of vector lengths into groups based on certain rules. After the objects are converted to numerical values, clustering based on length values makes it even possible to separate two objects that are very close to each other into other clusters. This makes it possible to equalize the size of clusters during clustering. The proposed clustering algorithm based on the square of the vector models is implemented by performing the following steps. As a result of the execution of these algorithms, the elements of K clusters separated have their own geometric meaning. The result of the proposed algorithms can be seen in Figure 5. It can be seen from Figure 5 that in the clustering based on the square of the vector model, the points that are very close to each other also belong to two other clusters. On the contrary, the points located far from each other belong to one cluster. This feature is another indicator that distinguishes the proposed algorithms from other clustering algorithms. But the main features of these algorithms is that the size of the clusters formed as a result of clustering are almost equal. Results. In order to check the ability of clustering algorithms to divide into clusters of equal size, 3 different data sets containing 1000 elements were used. Each data set was divided into 2, 3, 4 clusters. The elements within these clusters were enumerated and the results compared. Table 1. The results of the distribution of A, B, and C data into 2 groups using clustering. Table 2. The results of the distribution of A, B, and C data into 3 groups using clustering. Table 3. The results of the distribution of A, B, C, and C data into 4 groups using clustering. As can be concluded from Table 1, Table 2, and Table 3, the proposed vector length-based clustering algorithms recorded a good results in terms of the characteristic of equal-sized clustering of most data for 3 types of data. This situation can be seen in all 2, 3, and 4 clusters. The worst indicator belongs to hierarchical clustering algorithms. In all cases, the size of clusters were very different from each other. In all cases, a large part of the data belonged to certain clusters and small part belonged to other clusters. K-means and bisecting K-means algorithms performed relatively well as expected, but in no case did they perform better than the proposed approach. This result of proposed algorithms for solving the given problem can be seen in Figure 7. Figure 7 shows the distribution of the data A, B, and C into 4 clusters based on the proposed algorithms, and these 4 clusters are shown in 4 different colors. In conclusion, this research work was devoted to studying the possibility of clustering algorithms to divide data into clusters of equal size. For this purpose, this possibility of existing unsupervised clustering algorithms, hierarchical K-means, bisecting K-means, and DBSCAN clustering algorithms was studied. The result of the research showed that existing unsupervised clustering algorithms have strong capabilities in identifying hidden content in the data, but limited capabilities in dividing clusters of equal size. In order to solve these shortcomings, clustering algorithms based on the square root of the length of the proposed vector was proposed, and the steps of the algorithms were presented. Research results showed that this algorithm is very effective in solving the given problems. This was summary of the research which we are going to present today. Thanks for your attention.